we were looking at the equation of the Phillips curve under wage indexation, where we saw when we're assuming that lambda is a fraction of labor contracts indexed to the current rate of inflation, 1 minus lambda is updated based on expected inflation. So under this, we derive this as the equation of the Phillips curve. Now, this equation on the Phillips curve that we derived, we want to compare it with our original version of the Phillips curve without wage indexation. So originally we had pi t minus 1 is m plus e minus alpha ut. Under wage indexation, we derived this equation. So we want to compare the Phillips curve equation under wage indexation with the equation of the Phillips curve when we had no wage indexation. So let's do that. Now here the idea is that the coefficient of ut in the equation of the Phillips curve determines the influence of the unemployment rate on the inflation rate. So it's a coefficient of ut we're interested in because that will determine what is the influence of the unemployment rate on the inflation rate. Because you want to now mathematically prove that how wage indexation increases the effect of unemployment on the inflation rate. Right, so basically I want to compare old and new Phillips curve equations to show how wage indexation increases the effect of unemployment rate on the inflation rate. So for this, we're going to look at the coefficient of ut, as that tells us the influence of the unemployment rate on the inflation rate. So the larger the coefficient of ut in absolute terms, the larger the effect of unemployment rate on the inflation rate. We're talking about in absolute terms because we know unemployment rate and inflation rate have a negative relationship, right? So this coefficient is going to be negative, but it's going to be the absolute value of the coefficient that's going to measure the strength of the response of unemployment rate on the inflation rate. So larger this coefficient, the larger the effect of unemployment rate on the inflation. Now, coefficient of ut under no wage indexation is in absolute terms, the coefficient of ut under no wage indexation is alpha. Coefficient of ut with wage indexation in absolute terms is alpha by 1 minus lambda. So we're going to compare these two coefficients to see where the effect of unemployment rate on the inflation rate is higher, under no wage indexation or with wage indexation. Now, if I look at alpha, so alpha can be written as alpha divided by 1 because obviously it's alpha is alpha by 1 and then we have alpha by 1 minus lambda. Now notice both of these coefficients have the same numerator alpha, but the denominators are different. Here the denominator is 1. We can write this as alpha by 1. Here the denominator is 1 minus lambda. Now since lambda is between 0 and 1, we saw this before that lambda is between 0 and 1. It's the fraction of labor contracts indexed to the current rate of inflation. So it's between 0 and 1. Since lambda is between 0 and 1, this means 1 minus lambda is between 0 and 1. So this means that 1 minus lambda, which is the denominator of alpha by 1 minus lambda, is less than 1, which is the denominator of alpha. Right. So thus this means that alpha by 1 minus lambda, which is the coefficient of ut under wage indexation in absolute terms, is greater than alpha, which is the coefficient of ut under no wage indexation in absolute terms, right? Because see, this is because both have the same numerator, right? But the denominator of this is smaller. And for a fraction, the smaller the denominator, the larger the fraction. The numerators are the same alpha. Here the denominator is 1. Here the denominator is 1 minus lambda. 1 minus lambda is less than 1. So since the denominator of this fraction is smaller, this fraction overall is bigger. And hence, so since the coefficient of ut under wage indexation in absolute terms is greater than the coefficient of ut under no wage indexation in absolute terms, so we can say that wage indexation increases the effect of changes in unemployment rate on the inflation rate. Because like we said, the coefficient of ut determines the influence of unemployment rate on the inflation rate. The larger this coefficient in absolute terms, the larger the effect of unemployment rate on the inflation rate. And we have seen the coefficient in absolute terms here is alpha by 1 minus lambda. Here the coefficient in absolute terms is alpha. So this coefficient in absolute terms is greater than this coefficient. So the effect of unemployment rate on the inflation rate is higher under wage indexation. So we've mathematically shown how wage indexation increases the effect of changes in unemployment rate on the inflation rate by comparing the old and the new Phillips curve equation. And here what we're interested in is the coefficient of ut, because that measures the effect of unemployment rate on the inflation rate. The larger this coefficient is in absolute terms, the larger the effect. And we've seen that under wage indexation, the coefficient is larger in absolute terms. And we compared it by comparing their denominators because the numerators were the same. So the denominator for this was smaller when you had wage indexation. And the smaller the denominator of a fraction, the larger the fraction. So that's why we have shown mathematically how wage indexation increases the effect of unemployment rate on the inflation rate.